Here are the answers for the section 7-7 homework assignment. On page 272, we're asked to simplify. These problems are distributive property or FOIL, or if you look at number 5, notice you're squaring a binomial. These are all math skills that we've done this year. It's just the difference is we have radicals. Earlier this year, we had the same sort of problems, but then we had variables or just plain numbers. So let's use those same skills. Number 1, we multiply what's in front of the parentheses by both terms in the parentheses. That's called distributive property. 5 times 3 is 15. And then in the radical, you can also times. 10 times 2 is 20. Then we have minus, and then we have 5 times 1, which is just 5. And then in the radical, 10 times 5 is 50. Now we have a subtraction of radicals problem, like we did yesterday. Let's try to get like terms. We can think of 20 as 4 times 5, and we can think of 50 as 25 times 2. The square root of 4 makes 2, and 15 times 2 makes 30. This 5 here will stay inside the radical. Now on this piece, the square root of 25 is 5, and 5 times 5 is 25. And this 2 will stay in the radical. This is as far as we can go because these two radicals are not like terms. We cannot actually combine these to a single monomial. Number 3, this has the format of a FOIL problem. And it's even that special kind of FOIL where everything matches and we have a difference and a sum. So the square root of 6 times the square root of 6 makes a regular 6. Minus, and then the square root of 7 times the square root of 7 makes a regular 7. And 6 minus 7 is negative 1. Number 5, we want to square this binomial. You can use the shortcut version, or you can write the binomial down twice and then use FOIL. I'm going to use our shortcut pattern from earlier this year. Square the first term. The square root of 3 squared makes a regular 3. Then you double the product of the two terms. This product of this times this is the square root of 6. Then square that last term. The square root of 2 squared makes a regular 2. Now we can combine the 3 and the 2. That makes 5. And then plus 2 square root of 6. This is as far as we can go. Number 7, let's square everything that's inside those parentheses. So we're going to take the numerator and square it, and we will take the denominator and square it. Let's work on that numerator. It has the same format as what question 5 did. Square the 1, that makes 1. Then double the product of those two terms. That makes 2 square root of 3. Then square the square root of 3, which makes 3. In the bottom, 2 squared is 4. Now let's combine 1 plus 3 makes 4. And finally, we can divide both terms of the numerator by 4. 4 divided by 4 makes 1, and 2 divided by 4 reduces to 1/2 square root of 3. Number 9, we're back to a binomial times a binomial. This is a FOIL problem. So let's do the letter F. This one times this one. 5 times 2 makes 10. The square root of 6 times the square root of 6 is a regular 6. The reason is the square root of 6 times the square root of 6 is the square root of 36. But the square root of 36 is just 6. Okay, now let's do our outer product. We get negative 15 square root of 6. Now let's do the inner product. We get positive 2 square root of 6. And now the last, the 1 times the negative 3. That makes negative 3. Now let's combine. 10 times 6 is 60, and later minus 3, so that's 57. And then these two have like radicals. We can combine. Negative 15 plus 2 is negative 13 square root of 6. Number 11, do you recognize the format? Binomial times binomial, so it's FOIL. But it's the special case of FOIL because that's +1 and that's -1. Our outer and inner terms are going to cancel away when you combine. So we don't even need to do that step. This times this makes the fourth root of 4. And then 1 times -1 makes -1. Number 13, FOIL again. This one times this one makes the cube root of a to the third. Now let's do our outer product. We get plus a times the cube root of a squared. Now the inner product, we get -1 times the cube root of a. And now last, -1 times to a. That's -a. This first term can be simplified. The cube root of a cubed is just an a. Let me copy this part here. Finally, notice how there's an a here, but at the end a -a. Those will cancel away, leaving as the final answer a cube root of a squared minus cube root of a. These are not like radicals, so we can't go any farther. Number 15, we have a fraction, and there's a radical in the bottom. So the technique is to rationalize that denominator. We're going to times top and bottom by the same thing. Now, in order to cancel away the radical in the bottom, we want to times by the conjugate of this denominator. A conjugate is a binomial, but with the opposite sign in the middle. So we're timesing top and bottom by the square root of 7 minus 1. The original denominator is the square root of 7 plus 1. We're going to times by the square root of 7 minus 1. That's called the conjugate of that binomial. So in the top, we get 3 square root of 7 minus 3. In the bottom, look what's going to happen. The square root of 7 times the square root of 7 is a regular 7. And positive 1 times -1 is -1. Again, I don't have to do my outer and inner products for FOIL because this is that special case of a sum times a difference. So next step, we get 3 square root of 7 minus 3 all over 6. Now let's reduce. 3 divided by 6 is 1/2 square root of 7. And over here, 3 divided by 6 is 1/2. Number 17. Once again, we have radicals in the bottom. Let's multiply by the conjugate of that denominator. The square root of 3 minus the square root of 2. I'm choosing this on purpose so that when I times to this using FOIL, the radicals disappear. We're going to get -13 times the square root of 3 minus the square root of 2 on top. And on the bottom, here's what's going to happen. Square root of 3 times square root of 3 is a regular 3. Then positive times negative makes negative. And square root of 2 times square root of 2 makes a regular 2. 3 minus 2 is simply 1. So this is equivalent to -13 square root of 3 plus 13 square root of 2. We don't even have to put it over 1 because there's no need to do that when the denominator is 1. Number 9, same thing. There's a radical in the denominator. Let's multiply top and bottom by the conjugate of that denominator. We get 7 times 2 minus the square root of 5 all over 2 times 2 is 4, and square root of 5 times square root of 5 is 5. In the bottom, 4 minus 5 is -1. So 7 times 2 is 14, and then 7 times square root of 5 makes this, and this is all over -1. So final answer is -14 plus 7 square root of 5. Number 21, same thing, radical in the bottom. Let's times by the conjugate of that denominator. we get 13 times 5 square root of 3 plus 7 over, and down here, 5 times 5 is 25. Square root of 3 times square root of 3 is a regular 3. 25 times 3 is 75. Then 7 times 7 is 49. Next up, we have 13 times 5 square root of 3 plus 7, all divided by 75 minus 49. That's 26. Now let's reduce, because 13 and 26 reduce to just 1/2. So on the top we have 5 square root of 3 plus 7, all divided by 2. For the review assignment, we're asked, does this expression make a rational or an irrational number? Let's simplify it up as much as we can and see if there's any radicals left. So on the first one, 54 is not a perfect square. Let's factor 54 as 9 times 6. Right here, 96 is not a perfect square. Let's factor that as 16 times 6. And then for 24, let's factor as 4 times 6. All right, the square root of 9 is 3, and 1/3 times 3 makes 1 square root of 6. Now in the middle, the square root of 16 makes 4, and 3 times 4 makes 12 square root of 6. Now on the end, the square root of 4 makes 2, and 2 times 2 makes 4 square root of 6. Let's combine all these like radicals. 1 minus 12 is negative 11. Negative 11 plus 4 is negative 7 square root of 6. We can't simplify anymore, and there is still a radical left. So this is irrational. Because it's irrational, the directions say use a calculator, type this in, and get a decimal approximation. If you round it, it's about negative 17.1. Number 14, we're asked to simplify. So there's some different requirements to follow, and one of them is you can't leave a fraction in a radical. So let's do some work on this. Let's separate it into numerator and then denominator. Now over on this piece, is 972 a number that if you take the 5th root, you get an integer? Let's try that on the calculator first, just to find out. So you go 972, press the exponent key, and use a fraction for the exponent. The fraction is 1/5. That makes 3.958, etc. So this outputs a decimal. Let's try to rewrite this, where one of the numbers is something we can take the 5th root of. The first thing I'm going to do on the calculator is take 972 and divide it by 2. That makes 486. And then I'm going to go 486 to the 1/5 power to see if it's an integer. But it's not. It's still a decimal. So now I'm going to go 972 divided by 4. That makes 243. 243 is a perfect 5th power because 243 is 3 to the 5th power. So I'm going to write this as 243 times 4. Next up, the 5th root of 1 is just a 1. And then down in the bottom, we'll leave it as the 5th root of 8 for now. And then we have minus 1/2 times, but this part here we could actually figure out. The 5th root of 243 makes 3. So 1/2 times 3 is 3/2. The 5th root of 4 we have to leave in a radical. Another requirement out of the 4 requirements about simplifying is you can't have a radical in the bottom of a fraction. So we need to rationalize this. The 5th root of 8 does not make an integer. So we need to change 8 into something that we can find the 5th root of. So we need to times top and bottom by the 5th root of something. Now let's put some thought into what we want to times by. What is the smallest multiple of 8 that does have a perfect 5th root? That's 32. So we can change 8 into 32 if we times it by the fifth root of 4. This makes fifth root of 4 on top, and on the bottom, the fifth root of 32. But the fifth root of 32 is just 2. And then let's copy this other piece down. Notice that these are like terms. They both have the fifth root of 4. So we can combine them. 1/2 minus 3/2 is negative 2/2. And negative 2/2 is the same thing as negative 1 times the fifth root of 4. Or you might simply say negative fifth root of 4. This is as much simplifying as we can do. Next, number 16. The square root of 18 does not make a nice result, so let's rewrite that as 9 times 2. The square root of 8 is nothing good. Let's rewrite as 4 times 2. And the square root of 50 is not very good. Let's rewrite as 25 times 2. The square root of 9 makes 3. The square root of a to the 4th makes a squared. And then this 2 stays in the radical. Now in the middle, the square root of 4 is 2, and 3 times 2 is 6. The square root of a to the 4th is a squared. And this 2 stays in the radical. Now on the end, the square root of 25 is 5, and a 2 out front times 5 makes 10. The square root of a to the 4th is a squared, and this 2 stays in the radical. Notice we have like radicals. They all have the square root of 2, so we can combine like terms. 3a squared minus 6a squared is negative 3a squared, and negative 3a squared plus 10a squared is 7a squared. And remember, they all have the square root of 2 by them. So here's our simplified form. Number 32, we have an equation to solve. Let's remove the squaring by doing the square root of both sides. So when you remove squaring by square root, you just get the x plus 2. And on the other side, you get the square root of 45. Remember that when you solve by doing square roots, you have to take the positive and negative square root of the number. The quick way to show that is with a plus minus sign. Now to get x alone, let's subtract 2 from both sides. We get x equals negative 2 plus or minus the square root of 45. Now the square root of 45 can be simplified a little bit because 45 factors as 9 times 5, and you can find the square root of 9. So we get negative 2 plus or minus 3 square root of 5. Here are both answers written together with a plus minus sign. If you want, you can separate those into the two answers. One of them will be negative 2 plus 3 square root of 5, and the other answer will be whatever negative 2 minus 3 square root of 5 makes. Depending upon what kind of problem this is, you might have to actually type them both in a calculator and get 2 different decimals as your answer. The directions aren't clear here, so I'm going to leave my answer like this one here in the box.